Another useful concept which is used in the classical mechanics is the impulse. So here we will be dealing with the concept called as the impulse, because in second law of motion we from Newton's laws we can calculate the force. But suppose sometimes we encounter some examples under which we have got a lot of high amplitude forces. That means high value forces are acting for a shorter period of time, okay? So that means F is very much higher, but the duration for which the force is acting, it's very much lower, it's very much smaller, okay? This indicates these two conditions. So when such a case arises, we say that the impulse is generated onto that body upon which force is acted. Say for example, here is the wall, rigid wall, and I throw a ball onto it, okay? It is moving with the velocity v, but here when the ball strikes onto this wall, it stays with this wall for a very small period of time, very small period of time. But the force acted onto this wall is very much high, so the period of time is so much minute that we can't calculate accurately the force generated by the body onto this wall, or force applied by this ball onto this wall, okay? So in that case, force is very much higher, but the period of time for which the force is acted onto the wall is very much lower. But the product of these two, product of force and the time for which it is acting onto it, that is time of action, we can say time of action. This product of force and time, it is also called the change in the momentum. We can change in the momentum. I will show you how it is equal to the change of momentum. And this term, the product of force and time, this remains finite, still finite, remains finite, and it can be calculated, okay? It is possible to calculate. But for force is very much huge. So it's like this. Suppose with respect to time, this is the time axis, a force is generated at some particular instant of time. Say for this period of time, this is the delta t, but first force is 0 and after the effect of force is 0, fine. But when it reaches at this point, force becomes so much, it takes its peak values, fine. So there is like a peak seen in the graph, okay? So that means at this instant of time, there is a huge amount of force applied onto this wall, and this is called as the impulse. Because you might be well aware about the concept of impulse. Impulse means something which has got a very much high amplitude, okay? Similar case happens with the forces, okay? Fine. So how to calculate this very thing? How to solve this very problem? Here comes the concept of impulse. So impulse, even though force is very much huge, time is very much small for which it is applied, so time of action is very much smaller, but the product of these force and time is still finite and is still calculable, okay? It can be calculated, fine. So this is equal to the change in the momentum. How that is, I will show you here. I have told you this is the impulse. Impulse is equal to the force, and here this is the called as the impulse, okay? The impulse is equal to force multiplied by the time of action. time of action. So that means I represented by impulse represented by I is equal to the force multiplied by time of action. Fine. And we know from the second law of motion, what is the second law of motion? Second law of Newton. Second law says that the force is directly proportional to the rate of change of the momentum is directly proportional to force applied. So that means force is equal to the rate of change of momentum with respect to time, which is the second law of motion. Second law. Fine. So that means upon substituting here, we get I is equal to F is substituted by this. So we will get delta P divided by delta T multiplied by delta T. This and this goes roughly, I'm saying. It is not exact case because it is twisted mathematics done here. So for that, I will be equal to delta P. This is what I was telling you earlier, that the product of force and time of action is equal to the change of momentum. So we can calculate the change of momentum. From that, we can calculate the impulse. Fine. So for that, we will solve an example. We'll